Hello everyone, welcome back to the physics class of 8th standard. See, in the last section, we have started the sound topic, right? And we have discussed about the basic knowledge about sound. And we have discussed about sound is produced by a vibrating body. In that, we have discussed about activity 9.1, activity 9.2, activity 9.3, activity 9.4 and activity 9.5. Up to this we have discussed in the last session, right? So now we will start the next bit of the topic, that is sound produced by humans. So in this we are going to discuss how humans are able to produce the sound. So see, speak loudly for a while or sing a song or buzz like a bee. So for this what we have to do? We have to put our hands on your throat. Okay, just put your hand on your throat as shown in the figure. Okay, I'll show you one figure that is also there in the textbook, that is figure number 9.8. So what we have to do? We have to put our hand on the throat. Okay, as shown in the figure 9.8. So do you feel any vibrations here? Yes, we can feel the vibrations when we will talk. We will talk something else or we will produce a sound. That time we are getting the vibrations. We can feel the vibrations on the throat. See, in humans the sound is produced by the voice box. Okay, and this voice box is also called as larynx. Now put your fingers on the throat and find a hard bump that seems to move when you swallow. Okay, so what we have to do here? We have to put our hand on a throat and we have to find out a hard bump. Then this part of the body is known as the voice box. Okay, so where you can get the voice box? We can find it on the throat itself. Just we have to put our hand and then we have to find out a hard bump. That is nothing but our voice box. It is at the upper end of the windpipe. Okay, where it is located? It is at the upper end of the windpipe, and there we are having two vocal cords and stretched across the voice box. Okay, these two vocal cords are stretched across the voice box, right? Or we can call it as a larynx, in such a way that it leaves a narrow slit between them for a passage of air. Okay, that both the vocal cords are stretched in the way that we are having a very narrow slit between them so that only air can pass through that. Okay, then when the lungs force air through the slit, the vocal cords vibrate, right? What will happen here? When our lungs force air, okay, through the slit, the vocal cords starts to vibrate. Why it will starts to vibrate? Because of the narrow slit. The space between the two vocal cords is very small. It is narrow. Okay, so the air has to pass through that slit, right? So because of this only, what will happen? Both the vocal cords will starts to vibrate, and this vibrations will produce the sound. Then muscles attached to the vocal cords can make the cords tight or loose. When the vocal cords are tight and thin, the type or quality of the sound is different from that when they are loose and thick. Okay, so when the vocal cords, okay, around the vocal cords some muscles will be there, and that muscles make the vocal cords to tight or to get loose. When these vocal cords will be tight, at that time we are getting the sound which is not loud. Okay, and when these vocal cords are loose, at that time we are getting the sound which is much louder. Okay, so let us see how the vocal cords actually function. Okay, how actually it is producing the sound. This we can get the idea when we will discuss the activity 9.6. This activity is very safe for you people. This activity you can perform at home itself. So see, let me read the activity once. Take two rubber strips of the same size. Place these two pieces one above the other and stretch them tightly. Now blow air through the gap between them as shown in the figure 9.9a. As the air blows through the stretched rubber strips, a sound is produced. You can also take a piece of paper with a narrow slit and hold it between your fingers as shown in the figure 9.9b. Now blow through the slit and listen to the sound. Our vocal cords produce sound in a similar manner. So here we have to observe the two figures, that is figure number 9.9a, then figure number 9.9b. Here what we have to do in the first figure, that girl, she is having the two pieces of the paper, okay, and we have to keep it one above the other, and after keeping, you can observe here that we are having a very narrow slit between the two rubber strips, right? Then what we have to do, we have to keep on the mouth and then we have to blow the air. What will happen? Both the rubber strips will start to vibrate. So this is how vocal cord will function in the throat. Okay, then likewise only one more figure number they have given, that is 9.9b. Here also a boy, okay, he is having a paper and he has folded, that you can see in the figure. Okay, so like that only we have to fold the paper, and in the way we have to fold that, we should get a very narrow slit between that both the papers, and we have to hold the paper how they have shown in the figure 9.9b, and then we have to blow the air. Again what will happen here, because of the narrow gap, what will happen, the air wanted to pass through that narrow gap. So because of this, the paper will start to vibrate. So this is how our vocal cord will function. Okay, so this is about the activity 9.6. So this is about sound produced by humans. Now let us move towards the next bit of the topic, that is sound needs a medium for propagation. See, when you call up your friend who is standing at a distance, okay, one of your friend is standing just at a distance, he or she is standing, and you wanted to call him. So can you imagine how the sound is traveling from one place to the another place? See, one more example I will take here. In a class, the teacher is teaching, okay, she or he is taking the class. So that time many students are sitting in the class. Some of the students will sit on the first benches, some of the students will sit on the middle benches, and some of the students will sit on the last benches. So how it is possible that whatever the teacher is telling word to word, that can be listened by the first bench students also, and those who are sitting on the middle benches, and those who are sitting on the last benches also, they will also can hear the teacher's sound, whatever she or he is telling word to word. How it is possible? How sound is traveling from one place to the another place, right? So this all questions you will get. How does the sound propagate or travel to one place to the another place? How it is possible? So this we can understand in a better way by seeing the activity 9.7. So once you will do this activity 9.7, you will come to know that how sound is traveling in a medium from one place to the another place. And see, my dear students, this activity is also very safe for you, and you can do it at home. Okay, so I will read the activity 9.7. Take a metal or glass tumbler. Make sure that it is dry. Place a cell phone in it. Okay, what we have to do? We have to take a metal or glass tumbler, as you can see in the figure, and we have to make sure that it should be totally dry. Okay, then inside we have to keep our cell phone. Then ask your friend to give a ring on this cell phone from another cell phone. Okay, what we have to do? We have to tell our one of the friend to give a ring to the phone which is present inside the phone. Okay, with the help of the another phone. Then listen to the ring carefully. Then what we have to do? We have to concentrate on the ring. Now surround the rim of the tumbler with your hands. Okay, then put your mouth on the opening between your hands. Okay, what we have to do the next thing, you can observe in the figure. Okay, that is figure number 9.10. How that boy is holding the glass which is having the mobile phone inside. In the same way we have to hold the glass on the mouth and we have to hold it. We have to cover the glass with the hands. Now indicate your friend to give a ring again. Now again what we have to tell to our friend? Again to give a ring to the phone which is present inside the glass. And now listen to the ring while sucking air from the tumbler. Okay, when your friend will give the ring, at that time what we have to do? We have to suck the air which is present inside the tumbler. Okay, now the question arises, does the sound become fainter as you suck air? Okay, so what is the question here? When we will suck the air, at that time the loudness of the sound is becoming decreased. Why it is? It is so that sound cannot travel in the vacuum medium. Okay, so what is the thing here? Sound cannot travel in the vacuum medium. So again if you remove the tumbler from your mouth, okay, what will happen here? Again the sound will come louder, right? So why the sound is becoming lower here when you will suck the air from the glass? Here you are creating the vacuum medium. By sucking the air, what you are doing? You are creating the vacuum medium, right? So sound cannot travel in the vacuum medium, right? So it is possible that the decreasing amount of air in the tumbler had something to do with the decreasing loudness of the ring, right? Indeed, if you had been able to suck all the air in the tumbler, you will not listen any sound. See, if it is possible with us to suck all the air which is present in the tumbler which is having the mobile phone, if it is possible with us, then we can find that we cannot hear any sound. Why? Actually, sound needs a medium to travel, right? Sound needs what? Sound needs a medium to travel. When air has been removed completely from a vessel, it is said to that there is a vacuum in the vessel. Okay, so when we will suck the air from the tumbler, if it is possible with us to suck all the air which is present in the vessel, then we are creating a vacuum medium. So the sound cannot travel through vacuum medium. So here the question arises. What that question? Does the sound travels in liquids also? So let us find out the answer for this. Okay, so the activity 9.8 will help us to find out the answer for this question. So I will read the activity 9.8. Take a bucket or a bathtub, fill it with clean water, take a small bell in one hand, shake this bell inside the water to produce sound. Make sure that the bell does not touch the body of the bucket or the tub. Place your ear gently on the water surface as shown in the figure 9.11. Okay, so according to this activity, what we have to do? We have to take a bucket or a bathtub and we have to fill it with the clean water, and then we have to take a bell in one hand, and that bell we have to shake inside the water. Okay, and we have to make sure one thing, that the bell should not touch the body of the bucket or the tub. In that way we have to shake the bell. And likewise only we have to keep our ear gently on the water surface. Okay, and here also make sure that the water should not get inside your ear. Okay, just we have to put our ear on the surface of the water. You can observe that how that boy is doing in the figure. Okay, figure number 9.11. Now can you hear the sound of the bell? Does it indicate that sound can travel through liquids also? So see, let us find out if the sound can travel through solids also. See, sound, if that boy will shake the bell, what will happen here? Only little bit of sound we can hear. But the people who are standing outside, they cannot hear the sound of the bell, right? Why it is so? Because inside the water tub, there is a vacuum medium. Because of that vacuum medium, we cannot hear the sound of the bell. Getting all of you? So here that boy is shaking the bell inside the bathtub, right? Because of the water, we cannot hear any sound. Then like that only. So here the question arises, can sound travel through solids also? So we can find out the answer of this question when we will go through the activity 9.9. So in this activity, we have to take a meter scale or a long metal rod and hold its one end to your ear. Ask your friend to gently scratch or tap at the other end of the scale. Then what we have to do here in this activity, we have to take a meter scale or a long scale which is of metal. Okay, so that type of scale we have to take and we have to hold it. We have to hold its one end on the ear. Okay, then we have to tell our friend to scratch or to tap on the other end of the scale. Okay, as shown in the figure 9.12. Then can you hear the sound of the scratching? Ask your friends around you if they were able to hear the sound. So see, what is there in this activity? We have to take a meter scale, okay, or a long scale we have to take, and one of the end of the scale we have to put it on the ear, and we have to tell our friend to scratch on the other end of the scale, or just we have to tell him to put a tap. Then can you hear the sound? Yes, we are able to hear the sound, and even the friends or the family members, those who are standing around us, they will also get the sound. Then you can also perform the above activity by placing your ear at one end of a long wooden or metallic table and ask your friend to gently scratch the other end of the table, as you can see in the figure number 9.13. We find that sound can travel through wood or metal. In fact, sound can travel through any solid. You can perform interesting activities to show that sound can also travel through strings. Have you ever made a toy telephone as shown in the figure 9.14? Can you say that sound can travel through strings? We have learned so far that vibrating objects produce sound and it is carried in all directions in a medium. The medium could be a gas, a liquid or a solid. How do we hear the sound? Right? So this is what the next question you can ask. How we are able to hear the sound? So by doing this all the activities, one more we are getting the question, that is, how do we hear the sound? Okay, so this thing we will discuss in the next section. Thank you everyone.